Recall that to find the zero of a function, you can set the function equal to 0 and solve for x. And when you solve for x, those are your roots, aka solutions, also known as the x-intercepts of the graph, the point where the graph crosses or touch the x-axis. Now, we also talked about in a previous series the rational zeros theorem, and you will use the rational zeros theorem if you don't have any idea what any of your zeros are. So you come up with a list of possible zeros, and from that list you will pull certain zeros from there, test them using synthetic division, and in other words, find the zeros and use those zeros to help you find the others. So that method, yes, can be quite lengthy. But one of the first things you want to do is look at your polynomial. And if your polynomial can be factored, then one of the quickest ways of finding your zeros is to factor it and set it equal to 0 and solve for x. And those are your zeros, roots, aka solutions, x-intercepts. So let's go ahead and do that for this one. So I'm going to factor it out by taking the whole thing, setting it equal to 0. And because I have 4 terms, I'm going to use the factor by grouping method when you group them in groups of 2, the first 2 numbers together and then the second 2 numbers together. So now that we have it grouped, we want to look at the first group and say, what is it that these 2 terms share in common? As we can see that they share an x squared in common, so you would factor that out. When no numbers have anything in common, they do have a 1 in common, so we'll factor out. And we have to factor out a -1 because whenever the first term starts with a negative, you factor out a negative. So we'll factor out a -1 there. And so we still have a GCF here. We have a GCF of x plus 3. And what is left would be x squared minus 1 that you see there in blue. Well, x squared minus 1 is a difference of squares, which can be factored into x plus 1, x minus 1. So we actually have 3 zeros here, and our 3 zeros are -3, -1, and +1. Here's what the graph looked like. Notice each zero is an x-intercepts. You have -3, -1, and +1.